Okay, I'm going to go over synchronous counters year 2 and just show you what we did in lesson. Let's go with this one, shall we? So this was lesson 1, and basically what we have to do is we have to essentially fill out the truth table. So I'll write the Boolean algebra if you want. That basically DA is a NAND gate, isn't it? So it's B NANDed with A. DB, so I'll move that around a bit so I'm not writing along there. DB is the same as A, DC is the same as B, and DD is the same as C. Okay, so what you do then, you start with obviously 4 zeros, and that's told otherwise. You could be told otherwise. So I'm just going to grab that pen up there. So you start with your 4 zeros and basically you work along. So DA here is the same as a NAND gate. A NAND gate truth table, I'd always write it down. A NAND gate is 1110. So feel free to write that down. So I know that I'm going to get a 1 out. Zeros for the rest, because the rest is like a shift register. Then it goes diagonally down. That's the key thing. So 1 0 0 0. And we keep going till it repeats. So those two into a NAND will give me a 1. Shift, shift, shift. Put that down there. 1 1 0 0. 2 1s into a NAND gate, as you can see up there, give me a 0. So it's going to be 0. The rest of the information shifts through 1 1 0. Write that down there. 0 1 1 0. We should get a 1 0 1 1. Feel free to pause this and finish it yourself, and then obviously you can check it, can't you? I've saved this in the notes, by the way. It's on your SharePoint. 1 1 0 1. Just double check 1 1 0 1. Yep. 1 1 0 1, and then finally it's going to be 0 1 1 0. Okay, so that's the end of that one. That will actually repeat to here. I'll look at the state diagram in a moment, but essentially there'll be 3 in the main sequence. All of the rest are actually unused in this particular one. We'll look at how to do that, but that's just a basic one. But the key thing is you'll notice that the information gets written diagonally upwards or diagonally downwards. That's the next sequence. That was what we did in lesson 1. Lesson 2, we went a step further. So lesson 2, we actually got given a sequence. So there's a sequence already in there. Notice the next outputs. I'll just put some arrows so you can see. You can see what's going on there, that the information is written down there. Then, when the pattern repeated, which is 0, 0, 1, that's when I want my pattern to repeat. We now have another 2 boxes. We've got the unused states. There are obviously 2 that are unused because there's 6 part of the main sequence. And then there's a bit that says logic. What do we do there? Right. So my unused states, let's have a little look. I always start with the lowest number. Has that been used? 0, 0, 0 has been used. 0, 0, 1 has been used. 0, 1, 0 is my next number. And then 0, 1, 1 has been used. 1, 0, 0 has been used. 1, 0, 1. I think, yeah, 1, 0, 1. Okay, then what we do is this box for logic. We actually apply the logic from the next output. So how do we actually get that logic? It's actually quite easy. This is where you're going to get marks in the exam. So they might ask you to work out the Boolean algebra for D1, D2, and D3. You might be able to spot it, but I'm just going to show you the longhand way because I want to just show you with the Carnot map just for D1 that we've got. Obviously, yeah, they are written Q1, Q2, Q3 rather than Q3, Q2, Q1. But don't worry about that. Don't let that phase you. I'm going to write it exactly like we would write it on a Carnot map. So let me just do this. So I just want to show you about the don't care state in this particular map. Okay. Sorry, I know I'm at home doing this over Easter. Q2, Q3. So 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. Right, okay. So let's put these 6 zeros or ones in first. So there's 6 zeros and ones here. So feel free to pause it, put them in yourself. 0, 0, 1, it should be a 0. 0, 1, 1 should be a 1. 1, 1, 1 should be a 1. 1, 1, 1, 0 should be a 1. 1, 0, 0 should be a 0. And then finally, 0, 0, 0 should be a 0. Right, the other two cases are don't cares. We are going to put logic in here, but for this particular thing, there'll be don't cares. I'm not going to stick X's in there because I'm going to change those in a minute. But the idea is for this truth table, they can be ones or zeros because they're not actually part of the main sequence. Hopefully that will make it easier for you to be able to group. Hopefully you can see straight away now. Oh yes, look at that. Apologies, guys, if you're colorblind. I've chosen the exact wrong colors there to choose, but there you go. What does that equal? That equals Q2. So D1 equals Q2. Okay. D2. Again, can we spot it? I think we can spot it. That's the same as Q3. And then I'll just write it over here. D3 equals, I think it's not Q1. As I say, whichever method you're comfortable with, those are quite easy. D2 and D3 and D1 are quite easy, but use a Carnot map if you're stuck. Remember the X's, the don't cares, they're really handy. Okay, so make sure you do that. So what do we do with the logic? We apply the logic that we've got from above. So look, D1 is the same as Q2. So look down here, Q2 is a 1 at that point. I'll do it in a different colour, shall I? Let's go for black. So Q2 is a 1 there and a 0 there. D2 equals the same as Q3, 0 and a 1. D3 equals the same as not Q1, 1 and a 0. Okay. Why actually bother doing that? Well, it helps with the state diagram. So let's just have a look at the state diagram. S0, S1, S2, S3, S4, S5, S6, and S7. Right, so let's make this page a wee bit bigger just so we can fit it all on. Okay, see if we can get the state diagram in here. Right, so we're going to start with change colour again. So state 0 is 0, 0, 1. State 1 is 0, 1, 1. State 2 is 1, 1, 1. State 3 is 1, 1, 0. State 4 is 1, 0, 0. State 5 is 0, 0, 0. So that's your state diagram. So then the idea is to see if there's any stuck states. So that's why you actually bother. Otherwise, why would you do the last bit, write your unused states? You want to see if it has any stuck states, which can cause problems on power up. So state 6 feeds into 1, 0, 1. Where is that? 1, 0, 1. Okay, 1, 0, 1 is not actually part of the main sequence. Where does state 7 feed into? State 7 feeds into 0, 1, 0. Oh dear, we can see we've got some stuck states here. So state 6, which is 0, 1, 0, actually feeds in to state 7, which is 0, 1. State 7, which is 1, 0, 1. So the idea of that is you can see now that you've actually got a couple of stuck states, so they won't get back into the main sequence. So that's the reason why you do that. So you might be saying, Dan, why are we not bothering with the arrows down? Well, it does actually work out that those arrows will go down there. However, you don't actually do it that way. You look at the logic. Okay, that's why I said logic. The examiner won't actually put that. The examiner sometimes puts it as just one truth table. So you need to be concentrating when the next output repeats. So just go down slowly, slowly, slowly. You'll see when it repeats. Stop then. Put your unused states in. and then apply the logic. If you have to get the logic, it's dead easy to do. You've done this way back in September of 2020, believe it or not. Yeah, so quite a while ago. Okay, so you should know how to do that one. Let's just have a quick look because we've got a bit of time. What time we got? We're on 10 minutes. Okay, 2017. So let's have a look. Okay, so we'll just have a little look at a random question. So you can see on here, you've got 3 stuck states, 4, 5, and 7. You've got one. Sorry, my fault. You've got 1 stuck state, S6. You've got 3 unused states, S4, 5, and 7. And you've got 4 states part of the main sequence. Okay. Okay, here we go. This is just the kind of thing they could ask. It's dead easy to do. Can you basically copy this? So the clocks all go to the same point. Get my pen out. Clocks go to the same point because it's synchronous by definition. If it's synchronous, it has to have the same clock, common clock. DA is the same as C. There's DA. There's C. That's a bit too far. I won't do the loop over, but I'll do a little node. DB is a NOR gate, so we need a NOR gate there, which looks like that. And it's A and C, so that's going to go to there. That one's going to loop round to there. And then obviously a NAND gate for this one. Okay, so obviously C is there, and B is there. Okay, so that's the kind of thing they could ask. Let's move it down a little bit, shall we? See what else is going on. Okay, here we go. So this one, if you look to fill out the sequence, I've actually deliberately kind of finished, so you know that it actually. Oh, what's going on with pen? That's it. So you can see that it loops right the way back round to the beginning. So look, 0, 1, 0. So literally, you're going diagonally up. 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 0, 1, 1, and 0, 0, 1. So you can see it loops all the way back. And then obviously, if it's asking you to do Boolean, you can use a Carnot map. You might be able to spot, if you're really good at spotting things, you might be able to try and spot something. I would be tempted. What we after is it asks for DA. Does DA look like one of them? No, it doesn't. I can see that it's C and B for the top bit. What about the bottom bit? I'm struggling to see something quite easy with that. It probably is something obvious. But with that one, just do a Carnot map. All 8 will be in the Carnot map. All 8 zeros and 1s. All 8 zeros and 1s from DA will be in a Carnot map. So just do that. Okay, to get your marks that way. I hope that's been okay for you guys. That's what they will ask. They'll ask you about to draw the circuit. They might give you the truth table half completed. They might ask you to put the Boolean into a truth table, which you can all do. Nice and easy. That was the very first lesson. And they might ask you about the state diagrams. Okay, and don't forget, obviously, when you stop, you apply the logic. So you write your unused states, then apply the logic to see where they fit into. Okay, hope that's okay. Hope you're enjoying your Easter, by the way. And I'll speak to you soon. Bye-bye.